Welcome back to Codeverse, where we simplify C++, one concept at a time. In today's lesson, we're taking things up a notch with a core concept used in real-world applications, structs, your first step into building custom data types in C++. You'll learn how to group related values, create flexible variables, and make your code cleaner and more powerful. Let's dive in. So, what exactly is a struct in C++? A struct, short for structure, is a custom data type that lets you group multiple variables under a single name. Think of it like a container or a blueprint for an object, instead of having separate variables for name, ID, and grade. You can bundle them all into one structure called student. Each variable inside the struct is called a member, and it can be of any data type, string, int, float, even other structs. Structs are perfect for modeling real-world objects, like cars, books, or employees, where each object has multiple pieces of related information. This makes your code cleaner, easier to manage, and more aligned with how we think about data in the real world. In short, structs are your first step into building organized, reusable, and scalable C++ programs. Now that you understand what a struct is, let's learn how to declare one in C++. It's easier than you might think. You start with the keyword struct, followed by the name of your new type, usually written in Pascal case to distinguish it from variables. Then, inside a pair of curly braces, you define all the member variables that belong to this struct. For example, to model a student, you might include their name, ID, and grade, each as its own data member. Finally, don't forget the semicolon, at the end. Yes, structs in C++ need that semicolon. Once declared, your struct becomes a blueprint. You can create as many objects from it as you like. It's like designing a character sheet memo, then making multiple characters using that template. This is your first step toward writing real-world code with clean, reusable, and scalable structure. Ready? Let's see it in action. Now that we've declared our struct, it's time to use it by creating variables, or more accurately, instances of that struct. You treat the struct name just like a data type, similar to how you'd use int or string. So if we have a struct called student, we can declare a student like this, student s1. This line creates an actual object based on the blueprint of the struct, like building a real house from a plan. You can then access or assign values to each member using the dot operator. For example, s1.name equals Alice, s1.id equals 101, s1.grade equals 92.5, each variable, or object, you create holds its own copy of the member variables. This makes structs extremely useful for handling groups of data in an organized way. And yes, you can create multiple objects from the same struct, each with different values. Just like you can have many students in a class, each with their own name, ID, and grade. Let's walk through a few examples to see how this works in code. Now that we've learned how to create a struct variable, let's talk about how to initialize it. That means giving it values right when it's created. In C++, there are a few ways to do this, and the method you choose depends on what version of C++ you're using. The most common and modern way is to use brace initialization, also called uniform initialization. For example, if you have a student struct, you can write something like, student s1 equals, Alice, 101, 92.5. This automatically assigns values to the members in order, name, ID, and grade. It's simple, clean, and avoids repetitive code. Just make sure the order matches the order in your struct declaration. If you prefer, you can also initialize members one by one after creating the object, like we did earlier. Some developers even use constructors inside structs, but that's a more advanced topic we'll explore later. For now, understanding basic initialization will help you write more efficient and readable code. Let's try out different initialization styles in the next examples. Now let's explore how to access and modify the data inside a struct. Once you've created an object from a struct, like student s1, you can reach any member using the dot operator. It's as simple as, s1.name equals Alice, cout s1.grade. The dot operator lets you get or set values for each property individually. This is what makes structs powerful. You can treat them like a mini database of related values. Want to update a student's grade? Just assign a new value, s1.grade equals 95.0. You can also print or manipulate data using any standard logic, just like with regular variables. Here's a tip: when using structs with functions, you'll often access members either directly or through references or pointers, especially for larger structs. We'll dive into that soon, but for now, just focus on using the dot operator to control your structs data. Let's try it out in code. Now that we've mastered creating and modifying structs, let's take it a step further, by using structs inside functions. Why would we want to do that? Because it helps us organize code, reuse logic, and keep things clean. Just like we pass int, float, or string to a function, we can also pass an entire struct. There are three main ways to pass a struct to a function: by value, makes a copy of the struct. By reference, gives direct access to the original. By pointer, like reference, but with a different syntax. Here's a simple example by value: void print student, student s, cout s.name id s.id grade, s.grade, then call it with, student s1 equals, Alice, 101, 92.5, print student, s1, but remember, when you pass by value, it's just a copy. So any changes inside the function don't affect the original. If you want to modify the original, use a reference instead: void update grade, student s, float new grade, s.grade equals new grade. Want even more control? Use pointers. That's more advanced, but very common in real-world C++ code. In short, passing structs to functions makes your code more modular, readable, and powerful. Ready to try it out with examples? So far, we've seen how to define simple structs with basic data types. But what if you want to create more complex data structures? That's where nested structs come in. In C++, a struct can contain another struct as a member, just like how folders can contain other folders. For example, imagine a student has an address. Instead of putting strings for city, street, and zip code directly inside student, we can create a separate address struct and nest it: struct address, string city, string street, int zip, struct student, string name, int id, float grade, address. This keeps our code clean, organized, and easy to expand. To access nested members, we just chain the dot operator, s1.address.city equals Paris. That means you can go as deep as your structure needs, even 2, 3, or more levels. In real-world applications like games, databases, and simulations, nested structs are everywhere. So, when your data starts getting more detailed, don't panic, just nest it. Ready to see how nested structs work in action? Let's bring everything we've learned into action, with a real-world example. Imagine we're building a system to manage employees at a company. Each employee has 3 pieces of information: their full name as a string, their ID as an integer, and their monthly salary as a float. Your task is to define a struct named employee that holds this data. Create a function called printEmployeeInfo to display an employee's info. In main, declare one employee, assign values, and print the result using your function. Ready? Let's write the code together step by step. First, we define our struct employee. String name, int id, float salary. Next, we create the function to print the employee's information, void printEmployeeInfo, const employee emp. Cout name emp.name end l, cout id emp.id end l, cout salary emp salary end l. We use const and address here to pass the struct by reference. This avoids making a copy and ensures the function doesn't modify it. Finally, in main, we put everything together. Int main, employee e1, e1.name equals Amina Zara, e1.id equals 1001, e1.salary equals 4250.75, print employee info, e1, return 0. That's it. You now know how to define a struct, create an instance, access and modify members, and pass the whole struct to a function. This simple employee example ties all the concepts together, and gives you a practical foundation to build on. Let's now test your understanding with a quick quiz. Alright, time for a quick challenge to test your knowledge. Ready for a mini quiz? Let's go. Question 1. What operator do we use to access members of a struct? Is it A, the arrow operator? B, the dot operator? C, the scope resolution operator? If you picked B, the dot operator, you're absolutely right. Question 2. Can a struct contain another struct inside it? A, no, that's not allowed. B, only in classes. C, yes, we call it nesting. Correct answer is C, yes, we call it nesting. Structs can hold other structs, just like folders within folders. Question 3. What happens if we pass a struct to a function by value? A, the original struct gets modified. B, nothing is passed at all. C, a copy is made, so changes don't affect the original. You got it. It's C, a copy is made. That's why we use references or pointers when needed. Awesome work. If you got 2 out of 3 or more, you're Structsational. Now, are you ready for the final challenge? Now it's your turn. Let's put everything you've learned about structs into action in this final challenge. Your task: create a C++ program that defines a struct called book. Each book should have a title, string, an author, string, a price, float, a nested struct publisher that includes name and year. Then, create a variable of type book and initialize it. Print all its details using a function called printBookInfo. Bonus points if you use const and reference in the function signature for efficiency. This challenge combines everything we've learned so far: struct declaration, nested structs, initializing values, accessing members, passing structs to functions. When you finish, you'll not only understand structs, you'll be Struct level certified. Pause the video, give it a try, and then join us for the solution walkthrough. Awesome job! You've just completed one of the most important building blocks in C++, structs. Nested structs. Passing structs to functions. Real-world practice with a final challenge. Structs are just the beginning of organizing your code. But if you want true power and flexibility, it's time to unlock classes and objects in C++. That's what we'll explore in the next lesson. You'll learn how to build real-world software by combining code and data, the essence of object-oriented programming. If you learned something new today, make sure to subscribe to Codeverse. Like the video, comment your score on the quiz or challenge. And as always, keep learning, keep coding, and I'll see you in the next one.